So if we want to do this question in Desmos, which is not the most efficient way to do the question, the most efficient way is the one that you see in our video on Scatterplots in the SAT math playlist. But if you want to use Desmos, here's how you do it. You pick a few points. So let's say there's 0, 2.6. Maybe there is 25, 4. And maybe we pick this one right here, which is 45, 5.6. We're going to go into Desmos. We're going to add a table. We're going to enter in these points. I'm hitting 0 and then tab 2.6, tab 25, tab 4, tab 45, tab 5.6. I have entered in my 3 coordinates. I'm going to hit my add regression option. I'm going to go to exponential regression. I know that exponential functions are being tested here because of the answer choices and because the question itself tells us there's an exponential model. And what I get here for my equation is I get y equals 2.6 times 1.01 to the x. There is only one answer that comes anywhere close to having the, so in an exponential function we have y equals a b to the x. Our a value here is 2.6, our b value is 1.01, and there's only one answer that has anything close to those values. That's not 2.6, that's not 2.6, so b and d are out, and then the 0.017 obviously is not 1.01. So that's how you can use Desmos on this question. It's not a terrible way to do the question, but if you understand exponential functions and the fact that this is an increasing exponential function, so you can't have a multiplier that is less than 1, the fact that your y-intercept is at 0, 2.6 means that this y-intercept is out and this y-intercept is out, and then that would be it. You would have eliminated b, c, and d just based on the fact that this is an increasing exponential function and based on the y-intercept. That method is probably a little quicker and less clunky than the Desmos method.